Okay, here we are in part one. We're going to be looking at easy RESTful Web Services development with Netbeans 8. There's nothing special about Netbeans really. All code could be written manually, and there are other IDEs that support code generation, including Eclipse-based tools like myEclipse IDE, which I have personally used, and it's a great tool. Also, IntelliJ is a very popular tool, and there are probably others out there that can auto-generate code. But basically, I want to show you how easy it is to create RESTful web services using Netbeans 8. There are a number of topics we're going to touch on. REST itself, of course, JPA, Java Persistence Architecture, and some other foundational topics that are really outside the scope of what we're trying to do in this video. So these topics will give you links to additional information on them in the video notes. But basically what we're going to do is we're going to focus on creating RESTful web services that connect to a client-side HTML web app which connects to a database. So let's take a look at the database itself. I'm in Netbeans. You'll notice that I've got the manufacturer table in the sample web database, Derby database that's delivered with Netbeans if you download the all configuration. And this sample app has a number of tables. We're looking specifically at the manufacturer table. And when you view the data in that table, you see something along these lines. So this is the data that we're going to be accessing. Now, we could access multiple tables, but for this demo, we'll keep it simple. Now, let's take a look at the app itself, and then we'll look at how this app is structured, and then we'll look at how to actually create it. So I have it running, and here it is, nothing fancy. What you see is a table that has a number of records. This data is being pulled directly from the database. So basically, what a RESTful web service is all about is delivering data, only data, to the client-side code. So typically the client-side code is HTML5, some cascading style sheets, and a lot of JavaScript. And it's the JavaScript that talks to the server, calls the RESTful web services. The RESTful web services then deliver the data formatted as JSON back to the client, and then the JavaScript code unpacks it and modifies the DOM, and you end up with what you see. So, for example, here are the rows in our database. If we click on a link, we can modify the data, we can update it, delete it, save it, do whatever we need to do. Basic CRUD operations: create, retrieve, update, and delete. So that's what we're going to be building. Now let's take a look at the structure of the app, and then we'll look at how to generate it. First thing you need to understand is that using the wizards in Netbeans, we're going to be using JPA, Java Persistence Architecture, as our database access technology. And what that means is you have to have an entity class for every database table that you access. If you're familiar with JPA, this should be very familiar to you. If you're not familiar with JPA, I encourage you to research JPA and learn more about it. There are a number of good tutorials on the Netbeans website, as well as I'll provide additional information in the links in the video notes. But this is an entity class, and basically think of it as a class that represents a database table. And that means that it's going to have properties that mimic the columns, and it's going to have a number of methods, getters and setters, what have you, hash code equals, toString, other methods. Now, it uses a lot of annotations that are JPA specific, and what this does is it gives hints to the wizards as to what to do. So you have to have these entity classes. We're going to auto-generate these. They're a pain to write manually, and there's really nothing to be gained by doing it manually. You can always modify the generated code. So once you have an entity class, the next thing to do is to generate the service classes. And these are a little bit different from what most Java web developers are accustomed to. Most Java web developers are used to writing JSPs and servlets. We don't use any JSPs and servlets to generate at least in this example, to generate RESTful Web Services. Instead, this uses a special technology. In this case, it's called Jersey, which is implementation of the jax-rs specification for RESTful Web Services, and supported by Glassfish. So we're going to be using the Glassfish server. We could use other servers as well, but we're going to be using Glassfish. And basically, this is what a service class looks like. You'll notice that it has this unusual name, manufacturer facade rest. And that's just arbitrarily what the wizard named it. It took the name of the database table. Service classes tend to follow the facade design pattern, so it's a facade. And it's for REST, and so they added the word REST. So there's nothing special about this name. You could use any name you want. It also extends an abstract superclass that is generified for the manufacturer entity. And the advantage of that is that the superclass, I'll show you that, the superclass has all of the basic CRUD operations generified, so that you can use this superclass to generate RESTful Web Services for any table. So you have all your basic, here's your create method, here's your edit method, your remove method, some find methods, and all of these use JPA to do their work, but this is a generified, you can see the generic indicator here, for any data type you want. So that means any entity class representing any database table. So again, this isn't mandatory that you have this superclass. There's nothing special about this with regard to REST. It's just a good design. And so our service class is based on that superclass, and that means all of the CRUD operations are available to us. Now, what happens though is that we're going to be overriding these methods, and we're going to be using the RESTful annotations to turn these methods into RESTful Web Services. So we'll be explaining what all this stuff means a little bit later. Finally, this is a web application after all. This is the server-side code, but on the client side, we've got HTML. So there's going to be HTML, and that HTML is going to use lots of JavaScript. As you can see, there's lots of JavaScript here. And in particular, custom routine, this is the custom routine, which talks to our RESTful Web Services via URLs. Now, in this example, we're not going to show you how to write this code. We're just going to auto-generate it, and it's going to be using Backbone, which is a JavaScript framework, to help. But I'm not a Backbone programmer, and I don't intend to delve into it. I prefer straight jQuery, and when we get to part 2, I'll demonstrate the jQuery stuff in detail. But for this video, we're just going to auto-generate everything. I don't like auto-generating client-side code. And again, in part 2, you'll see some custom code for the client side. So that's basically our app, and let's get to showing you how to build it. Okay, we're going to first create a new web project. Now, I could use Maven to do this if I wanted to. But again, in the interest of keeping things simple, we don't really need Maven for this app because we're not going to be adding any third-party libraries. Everything's built in, and so we're just going to create a regular Java web app using Netbeans, and we're going to make sure that we give it a meaningful name. I'll just say Netbeans REST demo, and pick the right place to store it. Let's see here. Okay. And then we're going to want to make sure for this demo, we're going to use Glassfish 4, which Supports Jersey and the RESTful Web Services. We're going to use EE7, the newest technology in the enterprise Java world. And this is the name of our web app that we use in our URL. Okay. Then we don't need any other third-party libraries of any kind. Hit finish, and we have a regular Java web app. Now, there's nothing special about this. We can immediately run this if we need to, and we'll have a running web app. Doesn't have much in it. There's no server-side code. There's just an HTML page, and that's it. So, first thing we're going to need to do is create entity classes for whatever database tables we need to access. Now again, you could use pretty much any database you want, but in the interest of simplicity, we're going to be using the supplied Derby database that comes with Netbeans if you download the all configuration, and it comes with a sample database called sample, accessible at localhost 1527. So you want to make sure that that database is running. You just right click on it and say, if it's not connected, you right click on it and just say connect. And if you wanted to, you could look at the database tables and you could view data in them. Very simple. But all we want to do is be sure that we know what we're accessing and that the database is running. Okay, so now what we're going to do is we're going to reverse engineer one of those tables into an entity class. And that's very simple to do. There's a wizard for that. We simply right click on our project, new other, and if you go down to the category for persistence, you can see that there is a wizard to generate entity classes from the database. So again, it's the persistence category, and the file type is entity classes from database. So we're going to click next. Now you have to have what's called a data source. That's how Netbeans is going to connect, or JPA is going to connect. You should have a built-in data source called jdbc/sample for the sample database. Now if you don't have that, or you're using some other database, you're going to have to create a new data source. And basically you give it what's called a JINDI name, and you select one of your either existing connections or you create a new database connection. We're not going to bother with that because we're just going to use the built-in JDB sample data source. And once we select the data source, it loads in all the table descriptors. So these are the tables in that sample database. Now we could use all of these if we wanted, or some subset, but to keep things simple, we're just going to use the manufacturer table. We're going to add that as one of our selected tables. And if there were related tables, it would include those as well, but there aren't, and that's why I picked it, because it keeps things really simple. Then the next screen, we're pretty much going to go with all of the defaults, and what we really need to do is give a package name. Now, there's lots of package names that make sense. I like the term domain because an entity is part of the domain concept. It's the nouns used in your application, and in this case the noun is manufacturer. It's the manufacturer table. So I like to put those entity classes in a package called domain. You can use whatever name you want. Again, just go with all of the defaults here. It's going to create a persistence unit, which is JPA's way of talking to the database. Let it do all these things by itself. And we don't need to change any of these mapping options, but basically this gives you control of how Netbeans generates the entity class with respect to what the table looks like. So we're just going to hit finish, and we're going to have an entity class in just a few seconds here. And here's our package, and here's our entity class. And again, you'll notice that it's annotated this class with the entity annotation among others. It's given us all of the column names in our database mapped to properties. And this is essentially what an entity class looks like. So these are JPA annotations. They all come from this JavaX persistence package, and that's where the JPA stuff is. So these annotations tell JPA how to treat this information and how to map this back to the database. So that's mandatory. If we're going to be using the wizards to generate RESTful web services, we need to have these entity classes first. Now, once you have the entity classes, then you need to create service classes that provide the actual RESTful web services. And these service classes run on the server, and they're special classes. They're not servlets, they're not JSPs. They're actually EJBs, Enterprise Java Beans. So let's take a look at how to do that. So we're going to right-click on our project. Again, we'll go to New, Other. Now this time, we want to find the category for web services. And then, among all of the different wizards or file types, the one we want is RESTful Web Services from entity classes. Now notice that we also could have generated RESTful Web Services from the database, and then it would have done everything in one step. But I wanted to do it in multiple steps to show you that you can control what you're generating and when you're generating those things. So first we created the entity classes. Now we're creating RESTful Web Services based on those classes. So here we go. Now it wants to know which entity classes we want to use. So we're going to pick the one that we generated. And then the next thing is we need to give it a package name, where to put these classes. Now it's auto-selecting the name service, which is a good idea. If you don't have that, use whatever package name you want, but since it is a service class, I like to use the service as a package name. And then finally, we're going to go ahead and hit finish. And you're going to see that it's going to generate a bunch of stuff for us. First of all, it generated the abstract facade superclass that we talked about earlier. And then it generated the implementation of that superclass, our manufacturer facade REST. This is our RESTful web service. And a couple of things to point out here is that, first of all, a lot of the annotations are based on this JavaX-ws-rs. WS is web service, RS is RESTful service. So this is all stuff built into the Enterprise Edition 7 API. We're also using Java persistence architecture. And we're using EJBs, Enterprise Java Beans. So this is a stateless EJB. That's what this means. So this becomes a object that runs on the server. Keep in mind that because it is an EJB, that means you have to be running on a full application server, a full EE7 application server like Glassfish or like some other, well, JBoss Wildfly, for example, is another one. You can't use something like Tomcat to run EJBs because it doesn't support EJBs. So that's not a full application server. There's a version of Tomcat, I forget the name of it off the top of my head, that does, you just make sure you're running on a full Enterprise Edition application server. Now, that doesn't mean you can't create web services that are based on something other than EJBs. You can. But in this demo, and using these wizards, this is our only choice. So, the other thing is we have to have a root path. And we'll see how this works later. This is RESTful Web Services use the URLs to communicate. And this will become part of the URL. You'll see that later. And we can change that. Also, this persistent context unit name refers to something that was auto-generated. That's this persistence XML file. And this is how you configure JPA to talk to your database. And the rest of these annotations are REST annotations, which we'll get to in a moment. So we'll come back to this in a moment. The other thing that was auto-generated is this application config file. This configures our application for RESTful Web Service performance. And so this is auto-generated, and this is necessary on Glassfish. Okay. Now, if we go ahead and run this, we will have a RESTful Web Service application, but we don't have the client-side code written yet. But that's okay. I'm going to show you how to run this and test it before we have any client-side code. So let's go ahead and run it. So we'll right-click. We could right-click or just press the green arrow after selecting the project. So what this is going to do is it's going to compile everything, and it's going to deploy it to Glassfish. We can see that in the output console. We can see that Glassfish is starting up. And in a few moments, we will see the home page, which has nothing on it right now. And the main thing is this URL. This URL is the address of our application. But to access the web services, we're going to modify that URL. So let's go back to our Netbeans app here. And with the app running, there's a number of things we can do to test this out. You'll notice that we have this folder called RESTful Web Services. If we open that up, we can see the various methods that are exposed. So let's say, for example, we want to find all of the records in the manufacturer database. So we can right-click on this Find All method and say Test Resource URI. When we do that, what's going to happen is it's going to issue the correct URL to get at that information. So what this says is go to this server, go to this web app, and then use this suffix to access the RESTful Web Service. And what do we get back? Remember I said earlier, we don't get back HTML like a typical servlet-based web app would do. We get back just the raw data. And in this case, the raw data that we get back is formatted as XML. So what you're looking at here is XML, where each representing the various manufacturer records. There's record number 1, there's record number 2, and so forth. All right, now let's take a look at some options. Options for modifying the way this URL looks, and options for modifying the data format. So let's go back to our code, and let's take a look at, first of all, the what controls the URL. So this stuff right here that I've highlighted in the URL. Okay, so first of all, in our application config file, that's this guy up here, we have this web resources as part of our path. That's the root of our path. So if we go back, you see that yes, for our app, it starts with web resources. Okay, well, let's say we don't want that. Well, let's go ahead and get rid of it. Now, after the app hot deploys that change, we can go back here and we can remove that from the URL. And you'll notice now we get the same data back, but without the need for that extra piece of information. Well, we still have this domain manufacturer, which seems a little strange. Nothing wrong with it, but I'm going to show you what I prefer to do and what many RESTful Web Service API developers feel is the best practice, and that's to reference the information by a formal naming standard. And so, since this represents multiple manufacturers, what we'd really like to see here is manufacturers. Plus, something to indicate that it's an API In other words, it's an application programming interface that gets you to this data. So what I'm going to do is I'm going to go back to our code, and I'm going to add API as the root path. So in other words, whenever you have API in that path, that means we're getting to a RESTful web service. Now, again, this could be anything we want it to be. But it's a good idea to have something here that distinguishes it from the other code in your app. Maybe you do have some servlets, and you don't want those to be treated as web services. So this says only URLs that contain API will get at your web services. So that lets you be much more, use a much more rifle approach to getting at your web services. So that's the first change I'm going to make. The second change I'm going to make is I'm going to change this path in our manufacturer facade REST class to say manufacturers, plural, because it's really the manufacturers that we're accessing. So this more properly represents our data. So I'm going to save all that. It's going to hot deploy. You can see the progress bar at the bottom. We're going to go back to our URL, and this time we're going to modify our URL so that it has API/manufacturers. And from now on, that's how we get at our data. So now we have what is considered by many to be a proper web service URL. So to get at the data in the manufacturers table, you reference API/manufacturers. Now we're still getting XML back, and there's nothing wrong with XML. Lots of people like to use XML, but it turns out that XML is rather awkward to use in JavaScript because you have to parse it. You have to parse means you have to find all these little pieces like this address line and access the data represented by that. And that means a lot of extra work. If we represent this data in what's called JSON, J-S-O-N format, then we get back a JavaScript object, and it's much easier to access the data. So most RESTful web services support JSON in particular and optionally XML. Now we can actually support either or both. Right now, if you look at our code in our manufacturer facade REST class, you can see that clients will consume a choice of XML or JSON. Now what you really have here are what are referred to as mimetypes, M-I-M-E. And again, this is another one of those foundational concepts that we're not going to cover in detail in this video, but there will be links to it in the video notes. So the MIME type indicates the formats that can be returned by the web service. And when you offer more than one, then the client-side app gets to choose which one they want. But what we could do, if we wanted to, is we could remove one of these. I'm going to remove the XML from the find all method so that the only thing we get back is JSON. And what that means is now when we run our URL, instead of getting XML back, we're going to get JSON. So let's do a refresh here. And now we get JSON. So JSON's a format that basically uses, I'm not sure you can see this real clearly, but basically it uses a bracket to indicate an array. It uses a curly brace to indicate the beginning of an object. Then we have key value pairs. Here's a key, colon, and then we have a value. So key value pairs in an object, representing properties of that object. A very simple format, and remember that this comes back to your client-side code as a JavaScript object, so there's no parsing necessary. And we'll see how that can be used a little bit later. So, as you can see, we can have a choice of formats. We can provide multiple choices, or we can provide a single choice. If you provide a single choice, you don't get to ask for a format that you want. You just get what's available. If you provide a choice, then the client-side app, we'll show you how to do this later, can ask for a specific format. All right, so let's see what else. A couple of other things to be aware of is that there are lots of additional annotations that are used to make this code much more flexible. For example, let's say that I want to find a specific manufacturer by its ID. Well, what this says is that if you pass me the ID, then I will give you only that record. So let's test that. So if we go here and we do a slash, and we use, let's see, what ID do we want to use? Let's use ID, let's see, let's use this one here. Let's use this 199866982. Let's use that. So copy that and put that here. And now we get just the one record back. Again, we're getting it in XML format. We can change that. So again, if I remove this, save the change, let it hot deploy, refresh the page, and now we get the one record back as a JSON object. So if you look at the URL, what we've said is, I want to access the manufacturers, but I want this ID. So that's basically what this means. Now you can also add query string parameters, but again, to keep things simple in this tutorial, we won't be using any query string parameters. All right. Now, another thing that you should be aware of is that with REST, it's not just data being retrieved from the server and sent back to the client. You also want to be able to, for example, edit a record or create a new record, and you want to send data to the server. So typically with HTTP, what do? You post a form, for example. You post the data in a form to the server. So REST uses regular HTTP verbs like post, get, put, delete. And when you're posting data, for example, you have to send data to the server formatted in a certain way. And typically that would be formatted as JSON as well, although you could use other formats. So you can't do that easily without, well, you really have to have JavaScript to do that. And we're going to show you that later. But just bear in mind that JSON isn't just a format for data being returned back from the server. It's also a format that's used often in RESTful Web Services to send data to the service. So you have to have a format in mind for both directions. All right, so we have we've got our services written and performing. The next thing we're going to want to do is access this code from a real client. Now, one of the benefits of REST is that you can access a RESTful web service from any application. In other words, right now, we have a single application. This application houses our server-side code, the service itself, and it will soon, when we auto-generate the client-side code, also house the client-side code. But remember, web services in general are designed to be accessed from any web application, provided that application has access rights. So really, your web services can be made available to multiple web apps. But there's a rule, and that's the domain. There's a rule that says you can, by default, you can only access these services from the same domain that the server is running on. So in other words, if I create client-side code here, that client-side code has access to the services. But if I try to create a different web app that's running on a different server, it will not be given access to this web service by default. To do that, we need to run another wizard. And again, we're going to go down to Web Services. And what we want is what's called a cross-origin resource sharing filter. Cross-origin means that different web applications running on different servers can have access to this server's web service. So we're going to create that, and we'll put it in a, I'm going to put it in a package called util. And this is what it looks like. Now again, in the interest of time, we're not going to get into the details of how these CORS or cross-origin request filters work, but you should read up on that, and you should learn how to modify this to suit your needs. And then we'll be getting into a little bit more detail on that in parts 2 and 3. Without this filter, you would only be allowed to access the web services from this web app that we're running. This gives you the ability to access it from other web apps. All right, so we've got all of our server-side code written and performing properly. Now it's time to consider the client side. Just to show you how easy it is to get started with web services, I'm going to auto-generate the client-side code using a wizard in Netbeans. Now, the only thing about this is, and the part that I don't like, is that the wizard uses, it can only use Backbone, which is a JavaScript framework for simplifying and creating an MVC-style application. I don't like Backbone myself. A lot of people do. It's very popular. I just don't. I prefer things like AngularJS. I prefer Ember.js even more. And there's nothing that beats cutting your teeth on plain old jQuery, which is what we'll be using in parts 2 and 3. So that's my preference. You know, let your mileage vary. Okay, so let's go ahead and see how easy it is to generate this code. We're going to right-click. We're going to say New, and again, we're going to go to Web Services. And we're going to generate a RESTful JavaScript client. Now be careful here when you pick the wizard. We could create a RESTful Java client. That is not a web application. That's going to be a standalone application. And yes, RESTful Web Services can be accessed by non-web applications, just a standard standalone Java application, for example. That's what this wizard would be used for. But if we want to use if we want it to be a web app, we need a JavaScript client. So the JavaScript is what drives this. So we'll go ahead and say next. And we got to give it a name. I'm just going to go with the default REST client. This is going to be the name of the JavaScript file. And for now, we'll just put it in the web directory. It could go anywhere we want. But we have to base this on an existing RESTful web service. So we click this button right here next to this REST project resource. We click this button, and we pick the RESTful resource. That's this manufacturer facade that gives us our web services. That's the first thing. And so it's going to write the code based on what's in that class. The other thing is, just for simplicity, we're going to use this table sorter UI to present that grid that I showed you. And for some reason, I found this out by trial and error. You do have to check this box. You really shouldn't have to, but I found that, at least in the current version of Netbeans that I'm running, you have to check the box to add the Backbone.js file to the project sources. Otherwise, it tries to download them off the internet, and for some reason that didn't work. So now we'll click Next. And we got to create an HTML file to house all this code. So I'm just going to call this MFG, short for manufacturer, and it automatically adds the HTML extension. So now I'll hit Finish, and you're going to see that it's going to generate a whole bunch of client-side code. And here's what it did. It created this REST client.js. This is the JavaScript code that's used to access our service. Now notice, here's the URL. And you see we've got that /API/manufacturers. There's also references to other things in here. Again, this is all based on Backbone, and so again, I'm not a Backbone expert. I'm not going to go into any of this in any detail. But that code drives everything. We've got our HTML file. This is our manufacturer mfg.html. Here's all the JavaScript that's being used. Here's jQuery, here's Backbone, and some other things. There's some style sheets, plus our custom JS file. And then we've got basically a lot of HTML that's embedded in script tags. Again, this is Backbone type stuff. So now we should be able to access this page and see it work. So let's see if it works. So let's change our URL to access mfg.html and give it a second. And now we have our page. So there's our grid. And as you can see, we can navigate from page to page. We can create a new record, or we can edit an existing record. And all of the work to retrieve data and send data back to the server is done through these JavaScript routines. And that's basically it. So as you can see, with very little effort, we can generate a full CRUD-based, that's create, retrieve, update, and delete, application that accesses a database, provides workable, if not pretty, user interface. We can even sort these. Columns. Very workable. Again, not necessarily pretty user interface. And we really wrote no code. We made some modifications, but we really wrote no code. Now, in the real world, you would use this as a starting point, and then you'd get in there and you'd start modifying and customizing to your heart's content. But to get started, very, very simple. Now, in the next video, part 2, what we're going to do is we're going to look at using Spring Boot to make things even easier. And there'll be some bonus features you're going to definitely want to check out. So that's all for now. Hope to see you in part 2.